or the money that I want.
Okay. Yeah, that's a fair argument. Yeah.
Yeah.
Okay. Sawa. Thank you so much, guys. I hope you're settled in. So let me kick it back to Eric to take us through neural networks and teach us some timeless knowledge, Kenye, we shall use. So Eric, over to you, Maze. Let's give Eric a big round of applause as he comes on the stage. Just mweke emoji ya makofi bana as Eric comes. Nice, 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 nice.
Thank,
Eric,
thank, thank you so much, Emmanuel.
feel welcome.
So I first of all have to apologize because I was to come last week, and yeah, I had some commitments hapa na pale. Then we had to push this. So I'm really sorry for the people, and even for you, and even for creating time to join today. So I'll be taking us through through artificial neural networks, or neural networks in short. Yes. So I'll just be like, we'll be learning together, and I don't say that what I'll say is like it's cast on stone, but we'll be learning together. And feel free to comment. Feel free to ask a question. Yeah, and I see experienced people are also here. And I hope we'll enjoy together. So on to our topic. So artificial neural networks, like when you hear of a neural network, for me, what always came to my mind when I first heard of neural network or artificial intelligence, I used to think that like it's something that is it's working like the human neurons or the brain neurons. So that's what first came to my mind, because I first learned biology before I even learned came to know about AI, or even the neural networks. So today we'll be basically talking about the structure, application, and even some of the limitations of these neural networks. So I've prepared some slide here. Uh, we'll not code. I just decided that this 1 hour is a little bit short, and it's a time that we discuss together, get to learn from one another, yeah, and inspire one another. Yes. So basically, introduction to what neural networks are. So neural networks are computational models inspired by human brains, biological neural networks, and it consists of interconnected nodes, or what we call neurons, that process and transmit information. So that's basically what a neural or an artificial neural network is. So the way it you see, technology is growing, and for me, I can say that we are discovering, technology is helping us discover things that are through nature. It helps us learn through nature, then we improve our way of living, because brain is something that someone is born with, and through science, engineers or people, scientists have been able to learn how the brain works, and how this can also be how this can also be we you can train a model in a way that it mimics humans behavior, and it can be able to perform a task that maybe a task that requires me to do for 10 hours. It can be able to accomplish maybe in 5 minutes or in 10 minutes. So that's the inspiration. Oh, yes. So that's the inspiration, or the the the, the background, that uh neural networks have been built. So it it has grown with over the years, until now where we are. where we are moving to a era of like everything will like a era of AI and cloud computing, because AI and cloud computing goes hand in hand. So the neural network structure, it consists of three layers. So the first layer is the input layer, then the hidden layer, then the output layer. So as we move towards through this lesson, we'll be able to get to know like input layer, what it entails, the hidden layer, and even the output. Yes. So this is basically the introduction. Then or the, let's get to learn about the history and the evolution
Hey, Eric, I think you're breaking. Is it just me? Can you guys hear Eric clearly?
We
If
can't hear
sounds
him. He's breaking.
okay. I think on a network challenges. Okay, let me just give me a minute and I reach out to him.
we be then it's reached the 2010.
Hello, Eric, can you hear me?
Yes, I can hear you.
Oh, sorry, you are breaking. I think we lost you when you started talking about the history.
Okay.
Eric, are you with us?
Can you now? Hello.
Hello, Eric.
Yes, can you hear me?
Yeah, we can hear you, but inafika a point where you're breaking.
Oh, sorry. I think it was a problem with my clearly.
Sorry, you're still breaking.
Can you now hear me? Well,
Yeah, we can hear you, but you sound a bit far from the mic.
and now,
It's a bit better, yeah.
okay, now you can hear me.
Yeah.
Okay. So maybe let me just recap about the like what I was explaining. I was just
Okay.
giving an history of how AI or how neural networks have developed from 1940s
Mm-hmm.
until today.
Okay.
Yes, yes. So I've moved and it has evolved over the years until now we are in the deep learning era, or where we are leveraging on computational power and the big data. They say that data is the new oil for companies, and that's where the that's where big data comes in, and deep learning and and all these machine learning models that you see around, they have been built using data. That's why data is very important. So we are now in a period of the computational neuroscience and even the machine learning, where people are able to build complex AI models that can be able to to learn or to do to perform a task or improve the efficiency.
Yes, so let's, let us learn about the structure of the neural network. So we want to understand the layers, the neuron, and the weight and the biases. So the input layer always has four neurons. So it receives and processes raw data. Then after that, uh, the, the hidden layer, which has six neurons, it processes and transforms data, which is then which then produces the final prediction in the output layer. And the output layer always has two neurons. So 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 layers are organized structure, or they these layers are, let's say, like they're just like structures which data flows. Let's say a data is received, then it's processed, it's transformed, then it, it checks the pipeline or the transformation of data. Then the neurons, they are the processing units that compute weighted sums, and the weights are the connection strengths between the neurons. Then the biases are the thresholds or adjustments for activation. Yes. So because this this these neurons, like they're interlinked, they're interconnected. So that's basically the structure of a neural network. Then how a neural network learn, the training process from data to knowledge. So this is how it learns. Like data flows through the network from input to output. Then it goes to the error calculation. It compares the predicted output with the target value. Then from that, there's what we call back propagation, where error signals propagate backward through the network, and yeah, it adjusts. Then from that, they adjust weight using gradient descent optimization to ensure that it improves it improves the learning to give the desired output. So this is basically how it flows. So data flows forward through layers, and it flows from the point the data is ingested to the output, or the final output that it gives, or the prediction. So these are just common activation functions: the sigmoid function, the ReLU function. Yes, these are some of the functions that we will interact with in the like when learning neural networks. So we can then proceed to the types of neural networks and their different architectures for different problems. So the first one is the feed-forward neural network, where information flows in one direction from input to output. So it's basically used in the regression and classification tasks, where data data flows forward from input to output. Then there's the convolutional neural network. They are specialized for processing grid-like data such as images, videos, and mostly they are used in computer vision, where, let's say, you see, you do a video annotation or annotation of a music, or let's say a data label. You label, let's say you have a cow and a goat. Then you label, maybe with the, let's say you are using the bounding box to say that you label, this is a cow A, then this is a goat. Then it's the convolution neural network, or CNN, that is able to learn from, like, it learns, or it recognizes the images based on the labels, and you're able to train your model in a way that it can predict perfectly, or close to perfectly, the desired, or what you are desiring. Then there's the recurrent neural networks, or RNNs, that can process sequences by maintaining internal memory. So, example of use is language processing, time series prediction, like for like like maybe in stock in predicting stock prices. Recurrent neural networks are majorly used because uh, you realize that these stock prices are really volatile. That maybe a news or an information that gets into the market affects, let's say, there's something that happens. Majorly, I see it with these big countries. Maybe like right now, the Israeli and Iranian war. You see such kind of news, they really affect the market or the stock market, and it makes that market really volatile. That's why recurrent neural networks are really important when doing language processing, and even doing the time series prediction. So from so that we can go to applications in real life or neural network transformation, everyday experiences. So in the first place that we use this neural network is the image and speech recognition. For example, the Google Lens, Siri, and even Alexa, where you can communicate to a bot, or you can speak, then it records or it gets the information. Maybe you're asking what's the capital city of Kenya, then it knows that uh, it has data that is already fed into it, and it knows that it has the capital cities for all the countries in the world. Then it will iterate and check for Kenya, then gives you. So that's an area where it's being used in speech, in image and speech recognition. Then also in healthcare, let's say cancer detection, detecting malignant tissues, and even benign, malignant, and something like that. Yeah. So maybe in cancer detection, it's also a technique that is applied there. Then even in drug discovery, medical imaging, another place that it's used is autonomous driving, like the Tesla technology, object detection, and even path planning. Then it's also used in natural language processing. I believe this is something that we interact with almost every day. ChatGPT, Google Translate, Google Gemini, sentiment analysis. Like right now in Kenya, it was a sabasaba for today. Like you can use this technology to analyze the sentiment of Kenyan citizens. Maybe through X spaces, you can get to learn like what people are speaking about today's uh, today's Sabasaba commemoration, how it was, uh, what was the reaction of people in different counties, how did the police ensure that peace is maintained, or was there instances of, let's say, uh, people, citizens clashing with the police, something like that. And it can help in, let's say, it can help in planning, or let's say let's say the government can be able to know that such a place are the hotspot zone, and when there are demonstrations, those are the places that they should ensure that security is tight. Then also in a case, maybe it's a business like the Kenya Airways. It can be able to know like what people are saying about KQ, which services should they improve, or like which techniques should they employ to ensure that like yeah, their services are top notch, and people adopt what they are providing. So those are just some of the areas where we this real application of neural networks. So maybe industry experts, the leading tech companies that are using this. Google is really using this. Amazon is also using it. Tesla and even OpenAI is also leveraging on this technology. Yes. So they are leveraging in education, marketing, logistics, release, like people adopt and people use. So Google is one of the companies that we use most of these products, like maybe email, Gmail, Google Photos, Google Maps. We use a good number of its products. So it can learn the language learning app, and it can also be a virtual tutoring for assistance, uh, maybe in the education sector, where people like even the tech, tech companies that are providing education. And also in marketing, it can be able to know the customer behavior, targeted advertising, and even which content to generate. Also, even in logistics, can be able to know the route optimization kama ile ya Uber yenye Uber wanatumia. It's also demand forecasting, warehouse automation, and such kind of things. So it's something that is used in, let's say, me I can say it's all the industries they are leveraging on this. Yes. So from that we can just get to know the advantages. They say the advantages of neural networks. Why neural networks are revolutionizing AI. So it learns from experience. So data-driven learning improves performance over time. Neural networks get better with more data and more training. So it says the more the data, the better, the more accurate your model is. So this this is one thing that neural networks are good in. Like the, the more data you feed to it, the better your model. So your model becomes improved. Then it handles also unstructured data like uh, processes images, voice, text, and even you see data when it's from the warehouse, or when it's generated, it's messy and it's not structured. So data engineers have to organize the databases, decide on which infrastructure to use, and even ensure that data is put in the right format. So with the neural network, it can handle data, it can handle even unstructured data, and be able to process and give you the desired like prediction, or it can be able to learn from the data. So the nonlinear modeling power, it captures complex relationships traditional methods miss, and it can intricate patterns and interactions. So with even the back propagation technology, it can be able to retrieve back and get to know like is the final output really, like is it accurate, or does it give the desired output. So why choose neural networks? So 95% accuracy in many tasks, then continuous operations, although due to computational power, sometimes you realize that uh, these models they sometimes uh, are reduced in, let's say, like uh, how can I say, like they sometimes reduce in giving you, in promptly giving you like the desired output or what you want. Yes, and there are scalable solutions, so you can be able to achieve like something that do for one now, you can be able to achieve even in 5 minutes or 10 minutes. Yes. Then the cloud. So you realize that cloud services providers they always charge a fee for to when you use their cloud services. So sometimes these are hindrance to even innovation because like sometimes it's an hindrance to innovation. Maybe let's say to someone maybe like a student, they can't be able to pay for the cloud services, and you see for you to train this models, you require a very large data. So has barrier to entry for small organizations like startups, people who just have ideas, and so you see their dreams sometimes become shattered because they can't be able to afford that money to pay for the cloud providers. So the black box problem or opaque decision making process hard to interpret. Sometimes it's very difficult to interpret and trust the predictions or the suggestions that you get from when using this model. So overfitting risk. So sometimes you you train like you use large data to train the model, and you realize that you run into the overfitting risk. And sometimes also you realize that your data is small, so the underfitting risk also. So there has to be regularization to ensure that this data is it's not too large, it's also not too small. So there has to be a balance in between. Then also time and energy intensive. The training requires significant computational resources. So you realize that when training these models, you cannot be able to just use a laptop. Tuseme laptop yenye iko na RAM 4 GB RAM na chip yake pia iko chini, like your machine has to be very efficient for you to get the desired output, and for you to not to use so much energy when training like this model. So also the you see the requirements, the energy consumption, the training time. These are some of just the the limitations that these neural networks are. So addressing the limitations, some of the current solutions like the transfer learning to reduce data needs, regularization techniques to prevent overfitting, and more efficient architecture like mobile nets and also cloud computing for accessibility. Then for future directions, I think we have to invest so much in AI research and few short learning methods and neuromorphic computing and green AI initiatives to ensure that like you see even when using this neural network, it's something that is not time consuming, and it doesn't consume too much energy when you are training this model. Then maybe future direction. So future direction is like just basically what are the suggestions that I've said. explainable AI, so making neural network decision transparent and interpretable, such that someone who is like someone who is not some a layman person, let me quote and quote, can easily interpret the decision or the predictions of a model, and it's something that is transparent. Then neuromorphic hardware, so brain-inspired chips for more efficient neural computing to ensure that the time and the energy aspects are factored in to ensure that people doesn't have to use too much. Like you retrain. You see, it's a lot. It's taking a lot of time. Then also the quantum computing integration to enhance neural networks for exponential feedback. It realizes how quantum computing is really, it's also going hand in hand with artificial intelligence and automation. There are tasks that people used to spend maybe 2 years doing, it can just do in maybe in 2 minutes, it's done. Then also using advanced architectures like the transformers, attention mechanisms, and beyond to ensure that the architecture is scalable enough to handle this large data and to ensure that the model like the training and even the evaluation of model is is efficient. Yes. So these are some of just the revolutionary innovations on the horizon, the interpretable model, energy efficiency, and quantum AI to improve on the like to improve on the current on the current infrastructure or the current systems that are in place. Yes. So conclusions. So neural networks are the foundation of modern AI, and it has developed. Just imagine from 1940s coming to this far. We are in 2025. It has taken a lot of years, and people are building. And for me, I can say like it like people will it will it will it will continue to improve, and for me I see like the speed at which it will improve the AI model and the different industries that we work in. The speed will be fast because even with the help of other technologies like cloud computing and even robotics and automation and even quantum computing, like it's something that is going to really improve, and it's a technology that is really key at this moment because like AI adoption is increasing, and you realize that AI is really improving the efficiency, like our output. Like you bring AI and you bring the human aspect, and you realize that within a short time you can be able to achieve like you can be able to accomplish a task that you would have spent so many resources, you'd have hired so many people, spent so many years to do, and you are just able to achieve it within a short time. So neural networks mimic the brain structure with interconnected layers. So the application spans from healthcare to autonomous vehicles to entertainment industry to manufacturing and to so many industries that we have. So the powerful for pattern recognition and complex data processing. So the challenges include data requirements, interpretability, and even the time consuming aspect, like the uh, trying to build like computers that are having efficient chips to ensure that people like AI engineers doesn't have to use so much energy and time when training this model. So the future holds promise with explainable AI and even quantum computing. Uh, and you can agree with me that quantum computing is changing so many things, especially in the manufacturing industry, where it's able to automate and able to improve the time that we spend or a company spends to do tasks or the traditional way of doing tasks in the manufacturing industry. So uh, like uh, maybe just to like in summary, like neural networks or artificial neural network technology or uh, artificial neural networks is really important because we are moving to like we are advancing to complex AI models where which requires so much a large data to train and efficient also the computational power, efficient computers which AI engineers can just within a short time they are being able to train the model and doesn't have to spend so much energy. So that's why I believe that the neural networks knowledge is really important for us. People who are aspiring to be AI engineers, machine learning engineers, deep learning engineers, cloud computer vision engineers, and even cloud computing engineers. Yeah, it's a technology that it's really important because that's the future, and the future is now. We are already in the future, and the AI is really like it's disrupting things. It's changing how we were accustomed to doing things the traditional way, and it's really improving. It's not really. It's really improving our work and even the time, the energy that we spend in doing something. Yes. So that's basically the presentation that I was having. I don't know if there are questions or that people have asked. Uh, Over to you, Emmanuel.
Yeah, I think Sarah may celebrate. You may sink in. That's nice. Kaju has a question. Kaju, you can go ahead.
Kajo.
Thank you, Emmanuel. My question goes to Eric. Could you kindly repeat on the difference between CNN and RCNN? Is it RNN or RCNN? I don't know, something of the sort.
Eric, did you get that? You're muted.
Oh yes, can you hear me?
Yeah, we can hear you.
Okay. So let me just yes have the difference between the convolutional neural network and the recurrent neural network. So with the convolutional neural network, let's say it's specialized. Like these are type of neural network that uh, let's say it's not direct. Like let's say when you are handling an unstructured data. So unstructured data is like audios, images, and this technology is majorly used in image recognition. Let's say like in a project where you are trying to detect objects or you are trying to to classify or to train a model based on the labels. So that's basically what the convolutional neural network is. So with the recurrent uh, with the recurrent neural network, uh, it can process sequences by maintaining internal memory. So you see, when data is when you ingest the data, it goes through the three layers that we talked about: the input, the hidden layer, and the output layer. So with the recurrent recurrent neural network, it's able to maintain the memory. You see, this thing like these neural networks, they require machines with really uh, or laptops that are really efficient to be able to give you the desired output. So with the recurrent, like it's something, it repeats. How can I say? Like it 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 repeats over and over. Like it's something that is recurring. Like it goes. I don't know if you can see this image. Like it's a specific pattern. It's like a wave. It goes up then down, evo. Like it recurs to learn about the data and really give the desired output, as opposed to so it's just they're closely related. It's only that for the for the for the convolutional neural network, they 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 majorly uh, they majorly are used to identify to recognize objects or detect in object detection and even in classifying. Let's say we are doing an object detection to just the example that I use to check if this is let's say this is a human being, then another thing is a tree. So then you see, like it's able to map the image based on the level of the image. Then after that, after being trained on that, it's able to give the prediction that this is a human being, this is a tree, this is such an object. But on the other side, the RNN, it's majorly used in like processing, like uh, sana it is used in dealing with data that is sometimes, like I mentioned, data that is really volatile and it's changing, and it's able to learn from like when I map an image that this is a cow, it and I train a model on that, it knows that this is a cow, and that image it's recorded. But something like when dealing with the time series prediction, like it's something that this data keeps on changing and it's really volatile, but it's able to learn from the volatility. Even despite the fact that the data is highly volatile, it's able to learn and give you the desired prediction.
Yeah, Kajo, is that clear?
Yes, it's clear.
Mhm.
Yeah, actually, Nini, could Eric differentiate between CNN and RCNN? Because I'm aware also we have RCNN.
Okay, Eric.
Okay, he has asked about the RCNN, or
Yes.
the region-based convolution neural network.
Mhm.
So it like for the RCNN, it maps or it's trained based on the region. You see, Jikama, have you ever done something to do with data annotation or data labeling, where you label objects? Let's say this you label. You see, let's say Eric. You label my head, you label my legs, you label my fingers. So it's that it's the family of like you see this for the region-based convolution neural network, it's able to identify the regions. Let's say, it maps. It's able to identify that this is the head, this is the leg, this is the like this is the what can I say? This is the fingers. But uh, for the convolution neural network, it's majorly trained on the whole thing, like just able to identify like this is uh this is this this is a cat, this is a dog, but it it's not specified like this is the head of the cat, this is the tail, this is the leg, like something like that.
Okay, yeah, that's clear. Kajo, is that clear?
Yes, it's very clear. Thank you.
Yeah, I think De Santos anasema a good example is those who have interacted with the remote task. I
Yes,
think
yes,
there are tasks where unapewa data labeling.
yes.
Good. Okay, I'm looking at the chart.
Sarah is also the slide.
Cynthia Menge asks, is the
Yes.
plant recognition app one of the examples of usages of CNN?
Like is the
Plant recognition app.
oh plant recognition.
Yes.
Yes, it's an example of the CNN because it's able to map like let's say like you are in I've always seen these for like people who are really like people who are preserving this indigenous plants and maybe imagery projects where it's able to map like it can be identify it can identify a plant and even a weed. You see where like maybe in a maize plantation, it's able to identify a plant. This is a maize plant. This is a weed. Then maybe for the commercialized agriculture where they don't weed, they just spray pesticides so that to kill weed. It's able to like it's trained in a way that it can be able to only do that spray that only on weeds and it doesn't interfere with the plant. So anything do with most of the projects that do with image or image recognition, the convolution neural networks are involved, the CNN.
Okay, yeah, that's clear. Do we have any other question from anyone?
Someone is I've seen Sarah is also asking like where does the supervised and unsupervised learning come in? You
Yeah.
see, yes, so in simple terms, you see, supervised learning will be training data that is already labeled. Let's say you are doing a regression project or yeah, let me just use a regression project. So it's something that like you'll be like majorly you will be relying on the feed forward neural network. Like it's something that is really direct. Then for the unsupervised learning, like data is not clearly labeled. Let's say like when it's recognizing images or when you're doing even the clustering, people who have used even uh, algorithms like even k-means clustering. So it's basically like the data is not quite clearly labeled, but the model is able to learn from time to time based on the data that is fed on it, and it's able to improve the performance, the accuracy, and even yeah, the performance and even the accuracy. I don't know if that suffices.
Sarah, thumbs
Sarah,
up if that is clear. Oh, it's okay. Understood. Nice. Any other question? Going once. Kajo has a question. Go ahead.
This is out of today's topic, but it is in the context of the Google, these presentations that we've been having. I just saw an email that one of us received a scholarship, a full scholarship, regarding to the next cohort. So I was asking, like, what was the criteria and what was someone supposed to do for them to earn that scholarship? Because personally, I came in late when I joined, I think, the second day, so I'm green.
Okay. I think I'll answer that. So actually, the person who won the scholarship is Patrick. He's on the call. And the criteria for him earning the scholarship was Patrick had like he had encouraged people, like, instead of you just building things and then thinking of getting a job, why don't you build something for yourself and then sell that out, build a business out of it? And that is the mindset that we are trying to encourage for our second cohort. So that's why he won the scholarship. I hope that's clear, Kajo.
Yes, it is. Thank you.
Awesome. Yeah, I think Sarah, let me, for more details, let me just share a link to the cohort. Our upcoming cohort of the apprenticeship basically is an 8-week program that is targeting designers and young engineers who want to gain experience, like that gets them hired or gets them building a startup or building the next Google or whatever. So that is a program we run here at the Tech Hut, and we are doing cohort 2 right now. I'll share a link to that on the chat so you can review it. Awesome. Yeah, that's the link. Sawa. Any other question? Okay, I encourage you guys to apply for it. Like apply for the program. We are offering financial support for those who are unable to pay. So apply for it, fill in the form, and then we see where this takes us. So back to the call. If there's no other question from anyone, let me ask a question to Eric. As a beginner, I'm just getting started out in getting to learn about neural networks. Are there any resources, or maybe can you point me in the right direction when I want to start out in neural networks? Eric. Okay, I think I'm a drop. I don't know why. Sijui ameogopa swali. Oh, Eric, you're back.
Hello. Sorry, I'm really facing some challenges from my side.
Oh, okay.
You can hear me well.
Yeah, I can hear you well.
Hello.
Hello?
Hello.
Eric, I can hear you. Can you hear me?
Yes, I can
Did you get my question?
hear you. No, I didn't get your question. Maybe you can come up.
Okay, my question is for a beginner, someone who's just starting out, learning about
Would you
neural
come?
nets. Are you getting me, Eric?
Yes, I'm getting you.
Yeah, so for a beginner who's just starting out to learn about neural networks, where do we start? Like, where do I start learning about neural nets?
Okay, for someone who is just beginning off, for you to understand the concepts of neural networks, you first of all have to begin with the foundation, and the foundation is like you have to learn Python, which is a language for data. Like I can say a default language for AI. You have to first of all understand Python language, the libraries that are used, and basically like what all of the what is the essence of all those libraries, and how those libraries come to play a key role in helping you while when working on projects, and when leveraging on them to ensure that you don't have to you see libraries help you, and you don't have to write a lot of functions. You just import them, then you use them. So learning Python is a key, is very key, and getting to like you tailor your learning, getting to understand what Python language is, and how and the libraries it's used, and the libraries that are used even for deep learning, machine learning, and even AI projects. So after that, you can challenge yourself to start working, learning machine learning, and you start working on simple projects, and through that, you will gain confidence. And one thing that I have to say that you also have to be out in communities like this to ensure that you get to hear from people, and like what are they learning, what are people learning from other parts of the world, like basically to help you to be at par, and to ensure that like you are just up to the current information. Yes, there are so many skills to learn, but like for someone who is beginning, you have first of all to ensure that you are very good in Python, and you know the libraries that you can leverage when building projects in machine learning, AI, deep learning, yeah, and even computer vision. Hello, you can hear me?
Yeah. Thank you for that. I believe that's clear for everyone here. I believe you have your notebook down and you've noted that somewhere. Awesome. Any other question from the chat? Okay, maybe comments from the students. Like, I hope you found this session valuable. Just give us a highlight of the conversation. Like, what did you find valuable? What did you learn? And what will you be exploring? I hope your interest imekuwa sparked kidogo because you've been here with us for 1 hour, and I believe you may learn something. So just like to hear from some of you at random. Martin, can you hear me? Hi. Hello, Martin. If you are speaking, Martin, you are muted. All right, sawa sawa. So let's move to Jeff. Jeff, can you hear me? Jeff Mbita, are you with us? Jeff, am I audible? Like you can just react if you can hear me. I think I'm audible. So okay, fine. I think Jeff and Martin just joined. So I'd like to hear from David. What is your takeaway home from the call? D. David. Okay, so as we wait for D David, I see Sarah says it's been eye-opening. I am currently taking a data science course. I found it insightful. Nice. Awesome. That's what we like to hear. Anyone else? Kajo, how about you?
The sessions have been very informative. Currently, I'm also taking a data science course, and it has really been so resourceful, especially because my interest is in building agents. The session that we were taken through by, I don't know, it was Caleb, so practical, and it was very resourceful. So thank you so much, guys. Na God bless tu sana.
Nice. Thank you, Kajo, and good luck in your journey. Hope to see something cool built by you soon. Cynthia says it sparked my interest. I need to dust my Python notes. Nice. So yeah, if you found something valuable on the chat, you can just, on these talks or AI, just ask, go on to LinkedIn Pale, share your experience, share what you've learned with people, tag us at the Tech Hut on LinkedIn. We like to see that. Like the best way for you to learn is teach it to someone else. Teach it to someone else, and the easiest way to teach it to someone else ni kwenda kwa social media and talk about it. By talking about it, you'll attract a community of people who share the same interest, and you'll learn a lot from that experience. So I encourage you, end up at the LinkedIn, Twitter, wherever you like, and share about this. Okay. Sarah, yes, we will have more sessions like this. This is the second time we are hosting an event. The first one was last year. We will have more sessions like this, definitely. I hope topics of interest will collect, like what are you interested in learning about? We get experts on that, get them talking to you so that we can learn more and grow together. Awesome. I think before I go, is Linux? Yeah, Linux is on the chat. Maybe Linux. Hi, how are you? Can you hear me?
Hi, Emmanuel. Yeah, I can hear you.
Nice. So Linux was a partner for this event. He's the lead of Lentex, a YouTube channel, Pale YouTube. Okay, so self-explanatory. But yeah, go check him out at Lentex and subscribe, like the videos, and watch the cool stuff he produces. So yes, Lentex imekuwa spelled right up hivi. I think Linux. Can you share the teachable machines thing you are showing?
Oh, okay.
Yeah, awesome. So we have, I think, teachable machines are a visual experience of what Eric just explained, how neural networks work.
Oh, okay. This is just something that you can try yourself. Doesn't need any experience. Let me share my screen. Can you see my screen?
Yes, we can.
Okay, this is something that you can experiment yourself. It's basically based on neural net. You can try to train your own machine learning models. It's teachable machines. Just when you search teachable machines, the first link here is from Google. So there are a couple of projects that you can build from here. You don't need any experience. You can just try to create your own models. For example, you can try the one for image project. Then let's say you want to train a model that can identify let's say flowers. So you can go to Kaggle. Kaggle is a resource for data sets. Kaggle, you can just search like flower dataset Kaggle. Okay, then you can download just by clicking download. I think I've downloaded already. I have here some data set. Like here an image, this one is sunflower, around 10 images. Then tulip, around 10 images. So let's upload it here. So you'll come to that interface, teachable machines. Then you choose your images. For example, flowers, train, let's go with sunflower. Then you select the flowers. I think it has loaded. Then you name your class. Let's say sunflower. This is a classification model. Then the second class is tulip. Then you upload your images. Go to tulip. Yeah, that is it. You can add as many classes as you want. Then you can just hit there are advanced options here. I have skipped it. I don't know if I can edit.
Maybe can you close the window, yeah, chat, so that you can see clearly? Nice. Yeah, okay.
I don't want to use the camera. Okay, so while training, there are some parameters that you can use here. We have the epochs. Epochs, I think, is the number of revolutions, the number of, not revolutions. It's called what? Loops. Training, number of training loops. Then the batch size is basically the number of images to train. During, like, you can train 4 images at a time instead of training 1 image at a time. Then you have here the learning rate. Learning rate is basically like how quickly do you want to move to the converging point. So lower learning rate takes a lot of time, but actually it's preferred. So basically you can just go with this the default ones. Then you just hit train. It will train your model. Then you can try your model. So you can upload file. For example, you can go online and let's try. Thought the images were small, our data set was small, but let's just try if it can. Let's say it can identify this sunflower. Save image. Download. Then choose this downloads. I don't remember the name.
It was in Zen folder.
Okay, here. Then is it the first one? Last month, early this year.
No.
All right, or we save again.
Yes, yeah.
It's just shopping. Oh, I think it needs a JPEG image, not a WebP. Okay, let's try. It's this one. Yeah, you see it has identified that flower. This one is a sunflower. Let's try one for a tulip. Let's check the first one. This save image. So the more it needs more images, the more the data set you use, or the more the images that you use, your model will become more robust. Let's try this one. You see it has identified this one as Tulip. So this is how the neural networks. You can try yourself. You can even export your model and then you can use it inside your application. You can use the TensorFlow the JavaScript version. This one doesn't need a backend. Here is a code. You just copy this code and you place inside your web application. So this is the first method that you can, as a beginner, if you just want to try out the training your own small models, you can use this website here, Teachable Machines. There's another website called
Linux.
Yes.
Before you move to the next website,
Yeah.
could you kindly try with a different image, maybe probably a maze image we see, whether what it's going to say?
For that, you need to have a default class, which we didn't include. So basically, it will give one of these, but maybe let's just try. But basically, ideally, you'll have 3 classes. First will be sunflower, the other tulip, then the other it will be just image of random things, so that it will give you the output like maybe a none when there is none. But let's just try. Maze.jpg. Yeah, you see it's identified as tulip, but you need to add another class here, anonymous class with just random images, so that when there's you upload a different plant, it will give you maybe maize but with a lower percentage. Maybe for example here, it would have said maybe tulip but 40% or 30% or 50%. Basically, you need to set your own threshold. For example, you can say your threshold is around 80. So when the model says that this is maize, but the accuracy is below 80, then you don't consider that as a valid result. But if it says that this is maize and accuracy it's above 80, then you consider that a valid result. So basically, you need to set that threshold. Is that okay?
Yeah, I think Kajo has a thumbs up.
Okay. Also, there's another website that you can use to learn. It's called Brain.js. So basically, also this one is a web version. If you have problems dealing with things like TensorFlow or PyTorch, this one is an alternative. It has examples here. For example, how to train a model to. For example, this one is a XOR function. You can train your own model. It's just a simple model. XOR, I think when the input is 0, 0, it's 0, 0, 1, it's 1, something like that, just for inputs. All this, you can just try. You can just look here and then try to create these models. It's very easy when you work with this one, because you don't have to install any libraries. You can start with this one, then go the deeper way, the one which Ochoma told you, learning about Python and the libraries and the stuff. Yeah, so that is it. That's what I can share.
Wonderful. Yeah, thank you very much for that presentation. Before you stop presenting, I have a question to you and Eric. Like, where does Hugging Face fit into all of this?
Eric, can you check that?
Eric. Like Hugging Face, the website. I know it has a couple of models.
Okay. I think there's something called, if I'm not wrong, transfer learning.
Mhm.
So ideally, you can download some models from ideally models on the Hugging Face. You can just download the model and then use it locally on your machine directly. Then there's another way called transfer learning, where you'll download that model, then you retrain that model with your own data to suit your own purpose. So that's how I've been using Hugging Face for my case. I don't have so much information about it. Basically, I just know it has some models. If you want maybe to have a model about something, maybe identifying cats or dogs, you can just go to Hugging Face, then look for that model, download it, then use it locally, or even retrain that model to suit your own purpose. Yeah.
Yeah, okay. Thank you for that presentation. Can you just give Lennox a round of applause? Yeah. Nice. Thank you, Sarah. Thank you, Eric. Thank you, Kajo. Okay, yeah. To all our participants, thank you so much for attending this final day of the Mastery Week. As we wrap up, I have a request to everyone. If you can just, can we take a selfie together? Like, can you just turn on your camera so that we can see you, and then you can have one big beautiful selfie. Nona D amekimbia from that idea, but can you just do that? Can you just turn on your camera, we see each other, ndo tukipatana pale kwa streets tusipitane, we get to know each other better. Kindly. Kajo, Patrick, I can see Eric, nice. Who else? Jeff, Linux. I could see Caleb for a minute. I can see Linux, nice. Yeah, so these are the faces behind the voices. Kajo, we're waiting for you. Patrick, we're waiting for you. Kevin De Santos, tunangoja kukuona.
I've opened my camera, sasa sijui what is not happening.
Oh, okay. D Crown, Brian Kiplimo, Bernard. Yeah, Kajo, I can see you. Nice to see you. Who else? Brian Kiplimo, Bernard. I can see Bernard. Nice, wonderful. Who else? Brian, we're waiting for you. Kevin, we're waiting for you. Patrick, we're waiting for you. Just turn on your camera, see lazima you turn on your sound, and then we can take Martin, nice to see you. Nice to see you. Nice. Patrick, nice to see you. Kevin, nice. Who else do we have? I need like two more people. Patrick, I'm waiting for you, man. Martin, you umekuja ukapotea. Yeah, Patrick, I can see light. Okay. So in at the count of 3, nataka unipe the biggest banana smile you can have, the biggest banana smile you can have. So 1, 2, 3, everyone. Show me your biggest smile and a thumbs up. Nice, nice. Thank you so much, everyone. Thank you so much for that. Hope to see you soon on our next event. Brian, umekuja 2 seconds too late. Sorry about that. But yeah, thank you everybody. Have a lovely rest of the week. Thank you, Eric. Thank you, Linux, for sharing. And as usual, keep it here at the Tech Hut, where we are geared towards unleashing your great. See you soon, man. I'll play some music. Tuonane baadaye.